Hello, in this video we're going to learn how to determine the reaction order by using initial rates method. Let's have a look at a question first. Consider the following reaction. We have a balanced equation given to you, and the question wants you to determine the rate law and to calculate the rate constant. We have two things that we need to do for this question. Typically, the question will give you a set of data, and inside the table over here, we have a series of experiments. We have 3 experiments for this example, and each of the experiment will have the information about the concentration of each reactant involved in the reaction above. Also, the initial rates will be provided to you. By using this information, we should be able to find what is the rate law, and after we have figured out what is the rate law, from there we should be able to find the rate constant value. So step 1, what we need to do is you need to write the general rate law for the reaction above, and that is quite simple. How do you do it? First, you're going to write the word rate in front, like what you have over here, equals to K. K is the rate constant, the one that we need to find afterwards, and you have the concentration of both reactants raised to some powers. Now, we do not know what is the power here and the power right over there yet. So for step number 1, we're going to represent the power, exponential power, with any kind of alphabet. Over here, I have picked M and N. You can use X and Y or A and B, depending on what you want to choose. By writing the general rate law, you will be given 1 mark. After that, for the second step, now this is the general rate equation or rate law. For the second step, what we need to do is we need to find the value or the number of M over here first. So we need to do it one by one. So I have decided to work out what is M first. So we need to find M. How do you do that? By comparing 2 experiments. So you're going to pick which experiment you want to compare to find out what is the value of M. To do that, we need to compare experiment 1 and experiment 3. Why? Because when you compare experiment 1 and experiment 3, you would be able to cancel out the concentration for ClO2 over here, and thus we will be able to work out what is the order of reaction for F2. So when you compare that, you're going to write it in this form. So experiment 1 divided by experiment 3. So rate 1, so what you are going to be doing over here, you're just going to write in the form of rate law. So you have rate 1, which is this, 1.2 times 10 to the power of negative 3, over rate 3, because we have picked experiment 1 and 3 to be compared, 2.4 times 10 to the power of negative 3, the rate constant, and you have the concentration of your F2 to the power of M, and the concentration of your ClO2 to the power of N for experiment 1 and experiment 3. So you're going to be plugging in all the values that you have in this table into your comparison down here. Remember, our mission now is to find out what is the value of M. So we need to find 2 experiments that when you compare them together, you should be able to cancel out this one. okay? Because we want to find m. So when you substitute the value, so this 1.2 times 10 to the power of negative 3 is from experiment 1, so that is rate 1. And the concentration of your F2 to the power of m, concentration of ClO2 to the power of n, the one on top here is for experiment 1, and the one at the bottom is for experiment 3. So make sure you have substituted the correct value in your comparison. So for experiment 3, the concentration for F2 is 0.20 to the power of m, and for ClO2 for experiment 3, the concentration is 0.010, and we have 0.0010 to the power of n. So let's try to cross out the things that we do not want to have in order for you to find m. Okay? So we can cancel out this because they are the same, and k can also be canceled out because the rate constant will be the same for all of these experiments. So they have the same value. When they have the same value, you can cancel them out. When you cancel out n and k right there, you are left behind with the number right here and also the one right there in purple. So what you have is this after you have canceled that out. And when you work that out, you should be able to get something like this. So you have 0.5. So the numbers that you have right here on the left-hand side is 0.5. And the number in purple will be 0.5 to the power of m. So how do you solve this? So we're going to use ln. We're going to use ln 0.5 equals to, I'm going to put ln on both sides. Now, this to the power of m right there will be written in front of that. So when you do this step right here, when you move ln 0.5 on the right hand side to the left hand side, you should be able to get m equals to 1. When we have m equals to 1, that means it is first order with respect to F2 reactant. So we have found out the F2 order right over here, which is first order. Now we're going to move on to determine the order of reaction for ClO2 reactant. Step 3. We will be doing the same thing, in which you're going to be comparing two experiments for you to find the value of n. This time we're going to compare experiment 1 and experiment 2. The reason why we want to do that is because we want to find the value of n, which is for the ClO2 over here, and we will be able to cancel out the concentration of F2 right there, because when you compare experiment 1 and 2, they have the same concentration for F2 reactant. It's the same method like step 2 just now. So we're gonna divide experiment 1 with experiment 2, and you are going to be writing the rates law for experiment 1 right here and the rate law for experiment 2. Just like what we have done for F2 concentration for step 2, we will take the value that we have been given in the table and substitute those values correctly into the position right there. Rate 1 would be 1.2 exponent -3. Concentration of F2 for experiment 1, 0.1. Concentration of ClO2 will be 0.010. And then rate 2, the initial rate would be 4.8 exponent -3. And the concentration for this, F2, for experiment 2 will be 0.10. And the concentration for ClO2 in experiment 2 would be 0.040. It will look like this. Okay, make sure the substitution will be correct. So when you look at the purple bits right there, now we can cancel out for the F2 reactant to the power of m. So we can cancel this and cancel that. And since the rate constant is the same for all of the experiment that we have for this reaction, we can also cancel that, leaving behind that and the green bits. So when you calculate the blue bits right there, the comparison between the initial rates, and the green bits right there, the comparison between the concentration for ClO2, we have this value right here. So all of that will be coming out as 0.25, and the green bits right over there would be 0.25 to the power of n. Same like what we have done for concentration of F2. We're going to times ln on both sides. So I'm going to have ln 0.25. Okay, so ln 0.25, and that n would go to in front of that ln. When you move ln 0.25 on the right hand side to the left hand side, you're going to divide that with this ln 0.25. Thus, the value of n will be equals to 1. So we can conclude that the ClO2 will also have a first order reaction. When you write this statement over here, you will have 1 mark. Okay, this calculation over here, okay, this whole thing that you have over here would be 1 mark. And comparing the right experiment, you have 1 mark. This 1 mark for the F2 just now, and this whole thing 1 mark. Comparing the correct experiment, you have 1 mark. Okay, now what we need to do is we need to write the full rate law for the reaction. The general rate law that we have written in the beginning is this. Since m equals to 1 and n equals to 1, therefore the rate law for the reaction is that. So by writing the correct rate law, you would have another 1 mark. You don't have to write the number 1 over here because they know that if you have to the power of 1, then it will be written in this way. If you have to the power of 2, then you're going to write 2. Okay? Next, we have found out the rate law for the reaction is this. Okay, so we have done that. The second thing that we need to do for this particular question is to find the rate constant. And it's quite easy to do that. We're going to take the rate law that we have worked out from comparing experiments, and we're going to take any values from any experiments value data, then we're going to plug that into the rate law. So if you pick experiment 1, make sure you're going to fill in here and there the concentration of F2 and concentration of ClO2, the values from experiment 1. Okay, so you have to decide whether you want to use the data from experiment 1 or 2 or 3. Okay, so in this case, I have decided to find K. I have decided to use experiment 1 values into the rate law. So I'm just going to focus on the value right here. Okay, I will be taking that value, substitutes into there, and that value substitutes into there, and the initial rates for experiment 1, for the initial rates, you're gonna put it in there. Okay, so you have to pick either one of the experiment. You can do this with experiment 2 or 3. So when you substitute all the value inside, you should be able to get something like this. I would like to remind you to always remember writing the units. Okay, because when you have the units, it will help you to identify what is the units of the rate constant. Different question, different experiment, different reactions, they will have different units for K. So right here, we do know that for rates, we do know that the unit for rates would be molar per second, okay, or molar per minute, or molar per hour. But in this question, it uses molar per second. So that is the unit for the rate. So that is the unit right here. And the units for concentration, okay, concentration is M, okay, molarity. So when you have 0.010 times 0.010 molar, you will have 1.0 times 10 to the power of -3 m squared. So if I move that to the other side, what will happen is, okay, so when I move this to the other side, we would get something like this. Rate constant, 1.2 times 10 to the power of -3 molar per second, divided by 1.0 times 10 to the power of -3 molar square. Okay, so since this molar square, if you divide that with M1 over here, we do know that if you cancel this, you're going to cancel that, and you will be left behind with M. Therefore, the units for this rate constant would be per molar per second. Okay, and the value over here you would get 1.2. So that is the value for the rate constant. Make sure you're going to have the correct units. Okay. The units is correct. Now let's have a look at the second example. In this example, the table of experiment looks slightly exotic because instead of giving you numbers, you have alphabets in the concentration and also in the initial rates. But you don't have to worry about this because the way you're going to solve this will be the same, exactly the same as what we have done for example 1. Step 1 for this question, so you need to write, you're still going to be writing the general rate law. Okay, and then note that the question asks you to find the rate law for this reaction. So the first mark that you will be getting is when you write the general rate law. Why you have the word general over here? Because it is not specific yet. You're still about to find it out. And the general rate law for the reaction above would be this. Okay, so we're going to represent the order of reaction for PM, for the concentration of Q reactant S to the power of N, and for the R reactant, I will represent the order of reaction as O. Writing the correct general rates law, remember you need to have the word rates equals to K. This is the complete one. When you have the complete one here, then you will get 1 mark. We have the general rate law as a reference on top. And step 2, exactly the same as what we have done for example number 1. So you're going to be comparing 2 experiments in order for you to find out the order of reaction. I would like to find O first because the concentration of P to the power of M and concentration of Q to the power of N can be cancelled out when I compare experiment 2 and experiment 3 together. Okay, so when 2 things can be cancelled out, I will be left behind with the concentration of R, which is to the power of O. And you're going to write it in that format. Okay, so experiment 2 divided by experiment 3. I have rate 2 and rate 3. And you're going to write the rate law for experiment 2 on top and the rate law for experiment 3 at the bottom. Okay, and after this, you do know that we're going to substitute the value of PQR and PQR right there, and also the rates by looking at the experiment that you are comparing. In this case, we are comparing experiment 2 and experiment 3. So when you substitute that, those values inside the comparison over here, you will get something like this. 2Q is the initial rates here for experiment 2. And 8Q is the initial rates right there for experiment 3, the one that we have picked for the comparison. And the concentration of P is A, concentration of Q is 2B, concentration of R is C for experiment 2, and experiment 3, concentration of P is A, concentration of Q is 2B, and concentration of R is 2C. Okay, then when you compare this, we do know that they are things that we can cancel out. We can cancel out that, and we can cancel out that one, also the K, leaving behind 2Q divided by 8Q and C to the power of O divided by 2C to the power of O, and you will get this number over here. So 2Q divided by 8Q, you will have 0.25. C divided by 2C, you will have 0.5 to the power of O. We're going to use the ln method. Okay, we're going to put, to get the value of O over here, I'm going to put ln on both sides, just like what we have done for example number 1. You solve that, and you have O equals to 2. By picking the correct experiments to compare, you have 1 mark. And by getting the value of O, you will get 1 mark. Of course, you need to write the statement. Therefore, it will be second order with respect to R. Okay, make sure it's correct. O over here is for our reactant. So don't get this wrong, okay? For this here, you get another 1 mark. Next step is step 3. We have done this, okay? Now we're going to move on to finding out the other 2 reactants. Step 3, what I'm going to do here is we're going to find M. Okay? We can find M. To find M, we can compare experiment 1 and experiment 4. If you compare experiment 1 and 4, let me highlight that for you. If you compare experiment 1 and you compare that with experiment 4, you can see that you can cancel out that, you can cancel out R as well, and we can find out what is the value of M, because for concentration P, that one has been represented as to the power of M. So you do the same thing as what you have done for step 2. Like this. Okay, make sure you have experiment 1 compared with experiment 4. Over here, if you look closely, I have replaced O with 2. Why? Because just now we have found out that it is second order with respect of R. So you don't have to put O over here any longer. You can put the exact order for that. When you do all of this, you get 1 mark for that by comparing the correct experiment. And when you substitute the value inside, what you get is this. Okay, you have Q, experiment 1, rate 1 here is Q. Rate from experiment 4 is 2Q, okay, from experiment 4. And the concentration of the first reactant is A for experiment 1. This one is 2A, B, B, C, and C. So when you look closely, we can cancel that, and we can cancel that out, and also K, leaving behind this and the purple bits. Okay, so you have (0.5) for this. 1 over 2, you have 0.5. 1 over 2, you have 0.5. use ln on both sides, and you have the value of m equals to 1. So by finding the value of m, you have 1 mark. And don't forget the statements. It is the first order reaction with respect to p. You check that again. Yes, p to the power of m. So it's going to be first order. Okay, so that is another 1 mark. Next is to find out the next one. So we have done this, we have done that, and we are left behind with Q. Okay, so step 4, I think you can guess it. So we're going to compare 2 experiments. This time we are comparing experiment 1 and experiment 2. Let's see, experiment 1 is right there, and experiment 2. When you look at the experiment closely, you can cancel out this because they are the same. You can cancel out R as well because they are the same. And you are left behind with this. And that is the one that we need to find for Q. Okay, for right there. So you're going to write the comparison. So experiment 1 divided by experiment 2. You get something like this, and note that now for O, I have replaced that with the order that we have found out in the beginning of the question, and to the power of 1 for P over here. Okay, I don't have to write number one because they do know that this is to the power of 1. Now we're going to find what is N. So when you look at what you have there, when you substitute the value, Q is the initial rate for experiment 1, 2Q is the initial rates for experiment 2, and the rest of them. And you can see that we can cancel out this. You can cancel out C as well. So I'm just gonna show you this 2 there. So we can cancel out that, we can cancel out that, leaving this blue bits and the green bits behind. So when you solve that, you should get N equals to 1. So this is 1 mark, and by comparing the correct experiment, you have another 1 mark. And yes, we need to write the statement, therefore, it will be first order with respect to Q. You have another 1 mark. The general rate law given to us just now is the one here. Since M equals to 1, N equals to 1, O equals to 2, therefore, the rate law will be rates equals to K. Don't forget the word rates. Equals to your K, concentration of P to the power of 1, concentration of Q to the power of 1, and concentration of R to the power of 2. This will give you another 1 mark. Now, what if you need to find the overall order of this reaction? So it's going to be quite simple. So what you need to do is you're going to have M plus N plus O. Therefore, you have 1 plus 1 plus 2. And the answer is 1, 2, 3, and 4. So that is the overall order for the reaction. You have 1 plus 1 plus 2, you have 4. So the overall order of reaction is this. Moving on to the third example for this STR8CHEM video, we have a reaction on top. and the question wants you to find the rates equation. Okay. Also, you need to find the value of x in experiment 5. Value of x is right there, and that is the rates of reaction for experiment 5. Since experiment 5 does not have a rates of reaction, we can predict that experiment 5 will not going to be usable when you want to compare two experiments to find the order of reaction. That is one. Second thing over here, the question use rates equation. That is the same as rate law. Okay, so you don't have to worry about that one. So when you need to find the rates equation, we have to do the same thing. Step number 1, write down the general rates equation first. You have to write in full. You have to have rates equals to rate constant times with all of the concentration of the reactants raised to some power. You have 1 mark. Over here, if you realize I'm using X, Y, and Z, you can use A, B, C, or maybe P, Q, R. It's really up to your choice. Step 2, I think you can guess what's going to happen now. We're going to be comparing experiment. So first, we will find X. Okay, so we're going to find X by comparing experiment 1 and experiment 2. So when you look at the 2 examples that we have done just now, so you should be able to predict that. The way we're going to write the comparison is like that. Okay, so we substitute the value correctly. Okay, don't be careless. So you substitute the value from experiment 1 and experiment 2 into your comparison correctly. You should be able to get this value of 0.5 equals to 0.5 to the power of x. Always remember to look at your table over here and transfer the correct value so that you will get a very nice looking number over here, and it's going to be correct. Again, we're going to use ln method, and we have x equals to 1. By comparing the correct experiment, you have 1 mark. By finding the value of x, you get 1 mark. And you have to write the statement, therefore, first order with respect of the correct reactant over here, you get another 1 mark. Now, step 3, we have found what is x. Remember, we have 3 reactants. Now we're going to find y. So to find y, we have to compare experiment 1 and experiment 3. And the reason why is the same thing, because we can cancel out the things that we want to cancel out, and we can leave behind the reactants with the power of y. So comparing experiment 1 and experiment 3 will look like that. So comparing the correct experiment, you get 1 mark. And substitute all the value from the table into your comparison correctly. You'll get this, and simplifying that, you will have 0.5 equals to 0.5 to the power of y. We put ln on both sides to solve y, and you get y equals to 1. So this also you will get 1 mark, and the statement, very important, therefore it will be first order with respect to BR minus, you get another 1 mark. The third one, also the same method. We're going to find two experiments you want to compare. In this case, when you want to find Z, we have to compare experiment 3 and experiment 4. So when you look at the comparison, it will look like this. You substitute the value and you get that. Okay, so when you look closely, we can cancel K, we can cancel the purple bits, and we can cancel the green bits, leaving behind Z. So we can find that out and leaving behind your rates. And moving forward, you have 0.2 over 8 is 0.25, 0.3 over 0.6, you have 0.5 to the power of Z. And you'll get Z equals to 2. So this is 1 mark. Comparing the correct experiment, we have 1 mark. And the statement is going to be second order with respect of H plus. Okay, don't forget that is 2. So it will be second order with respect to H plus. So that is another 1 mark. Okay, so therefore the rates equation will be written as rates equals to K rate constant, concentration of BrO3 minus to the power of 1, concentration of Br minus to the power of 1, and concentration of H plus to the power of 2. Okay, and the overall order is also 1 plus 1 plus 2. You have 4. Okay. That one, if the question asks you to give, you will get another 1 mark. Now, we have done this. And now the question wants you to find the value of X over here in experiment 5. And how do you do that? We're going to compare 2 experiments as well. But this time, since we have known what is the rates law already, okay, so to find the value of X, what we need to do, we have to compare 2 experiments as well, experiment 4 and experiment 5, okay? But this time we do know what is the rates law, and we can substitute the value inside to find the value of X. So we compare experiment 4 and 5. Same like what we have done to find the order of reaction. And you're going to substitute the value of rate 4, rate 5, and all of the concentrations over here. Look, I have written all the order already. Okay, because we know that this is first order and second order. When you substitute the value inside, you should be getting this. Okay, you work out what are these values over here. Then when you switch that over to the other side, and do remember, since K is constant, you can cancel that out. And you just need to work out those values over here. And when you do that, you will get X equals to 3. So comparing the correct experiment, you have 1 mark. Getting the value of X, you will get another 1 mark.